Hi again, everybody, and welcome back. Well, up to this point in this chapter on potential energy and conservation of energy, we've talked mostly about conservative forces that do work that is conserved. Forces like gravity and like springs, where all the energy or all the work is accounted for between any 2 points in the system. Now we're going to be talking a little bit about non-conservative forces, or forces that do non-conservative work. And what non-conservative work is, or work done by non-conservative forces, it's it's some influence or some force that either adds work or subtracts work from the system. We've talked about how friction, and friction is going to be a very common non-conservative force. And an object can have energy, you can have kinetic energy, maybe sliding across the floor, but because of friction, friction will take that energy out. It'll turn it into different forms other than energy of motion. So friction is going to be a very commonly referred to non-conservative force. So our equation for non-conservative force is this, and I'm sorry this is really, it's kind of hard to see a little bit right here, but right here that should say NC, or non-conservative. All right, this little non-conservative, I'll write it in the C right there, right in the middle. Non-conservative work is the change in energy of the system. Of course, change in energy always means energy final minus energy initial. Okay. And the energy at any one point in the system is kinetic final minus kinetic initial. We talked about that in the last section when we talked about conserving all the work. And the potential final minus potential initial. Okay, so if there's any difference between the total kinetic energy and the total potential energy, it's because some sort of work was done on the system. Either subtracting it from the system, like friction tends to do, or you can also have non-conservative work done to the system that adds it. For example, a car that is coasting may have kinetic energy, but if all of a sudden you put it, as it's coasting, you put it into gear and step on the gas pedal, that engine is adding work to the system. So the car will no longer coast, but it will actually accelerate. So you can put work into the system too in the form of things like an engine. But in many cases, the non-conservative work we're going to talk about is due to friction, and friction strips the system of energy, making the final energy and the initial energy different amounts. And that's accounted for by this non-conservative work right here. All right. One way I like to oftentimes say it is that energy final, all right, energy final, that is kinetic and potential, equals energy initial of the system plus some non-conservative work. I always write it like that, and you may want to box it. I always write it with a plus because if it's positive non-conservative work, then that is added to the system, and so your final energy is going to be greater than it initially was. Or if it's negative work, like friction does, you're going to put a minus in here, and so it's the final is going to be less than the original. But for friction, the work done by friction is the force of friction, and we know that to be mu k. Oh, actually, I have it written over here. Sorry. Mu k times the normal force, which is mg. That's objects on a flat surface, times the distance. Here's our distance. And where does that minus sign come from? Well, because if we're going to be a little more complete about it, we're going to say that that's times the cosine. UK times mg times the distance times the cosine of 180. All right, of course, the cosine of 180 is -1, and so that's where that negative comes from. All right, so work done by friction is always negative. So in this case, you would put a negative amount of work in here so that the final energy of the system is less than the initial energy of the system. Okay, and this is funny, not realizing that this was all on my next slide. I kind of already wrote that for us. This is exactly what I just showed you. The non-conservative work results in a change of energy of the system. All right, initial energy plus a change in energy equals a final energy. All right, and this is what I had you box just in the previous on the previous slide, that the final energy is equal to the initial energy plus whatever non-conservative work is done, and that could be positive or it could be negative. In many cases, we're going to have it be negative. That is like friction taking energy out of the system. Okay, so this is the only difference between conservation of energy with non-conservative forces versus conservation of energy with conservative forces. If you have a loss of energy, or if energy is not conserved, you need to account for that energy or work that was not conserved. And so we're doing that in the form of that non-conservative work. All right, so whatever the difference is between initial and final, our change in energy or our non-conservative work is going to be the work that took energy out of the system, or in some cases put energy into it. Okay, so for now, we're going to stop this segment right here, and in the next one, I'm going to pick up at example 8-9, and we're going to apply this to that example. Thanks for following along. I'll see you on the next one.